From this step on, I will just expand the numerator here. Okay, so log, if you expand the numerator, what are you going to get? A plus root a plus x square, which will simply give you a plus x. I'll get a minus x similarly, and 2ab term will be there. So plus 2 root a plus x root a minus x divided by 2x. Okay. So now you have, if you see here, this plus x and this minus x is going to cancel. What are you going to left with is 2a plus twice root. Now you can move this a plus x, a minus x inside the bracket with a square minus x square divided by 2x. Now what you can do is you can cancel out the factor 2 from numerator and denominator. If you take common, 2 will cancel out. You'll simply get a plus root a square minus x square divided by x. Now you write this as log m minus log n. That is, now you write this as log a plus root a square minus x square minus log x. Okay, right. Now we shall differentiate. So you've got y is equal to this, therefore dy dx is equal to ddx of log a plus root a square minus x square minus log x. So that now if you differentiate the first log, let us differentiate the first log directly. Yeah. If you differentiate the first one, how will you differentiate? First you differentiate the log, right? And then what is inside the log? Right? Minus, and ddx of log x is 1 by x. Okay. Next. Into, now how will you differentiate this? First ddx of a you will get 0. Then you will get ddx root a square minus x square. Can you tell me what is ddx of a square root a square minus x square? Can you just try? I'll help you out if you are unable to say. ddx of this, can you just try it?
Sir, half to a
First is your ddx
minus
of a.
2x.
ddx of a is a constant, right? 0
Oh, that is 0.
plus, yes. And what is the ddx of this? First you differentiate the radical, right? What do you get? 1 by 2 root a square minus x square into the ddx of a square minus what is inside the
X square
radical,
minus
isn't it?
yes, sir.
Okay. So now this is what. So now what will happen is I'll get 1 by a plus root over a square minus x square. And here what will happen here is, see, ddx e square is a constant, so it will become 0, isn't it? Minus, what is ddx of x, x square? It is 2x. So you have 0 minus 2x, isn't it? So you can simply get a minus 2x. Do you agree?
Yes, sir.
Okay. So this is minus 1 by x. So now what you do is, this gets cancelled out. Okay. So now what you do is, now you take the LCM here. Just let me just write it in a simplified form. Minus x divided by, this is what you are getting, root over of a square minus x square into a plus root a square minus x square. Okay, minus 1 by x. Fine. Now we take the LCM.
Yes, sir.
This is x root. Multiplication of both the denominators will give you the LCM. And so that now in the numerator, what do you get? In the numerator, you get minus x square, right? Minus,
Yes,
and in
sir.
the denominator, what you get here is denominator. What you get here is root over of a square minus x square into a plus root over a square minus x square, isn't it? Just check whether you are getting this or not.
Yes, sir. That is.
So minus x square. Now what you do is you root over of a square minus x square, you multiply throughout. What do you get? Minus a root a square minus x square. And you get minus a square minus x square, because root a square minus x square into root a square minus x square is simply a square minus x square divided by x root a square minus x square into a plus root a square minus x square. Fine. So now you open the brackets in the numerator. Minus a root a square minus x square minus a square plus x square divided by x root a square minus x square into a plus root over a square minus x square. So what happens? See, in the numerator, this minus x square plus x square will cancel out. So that now in the numerator, if you take say minus a common, what are you left with? You're left with a plus root a square minus x square, isn't it? Let's check whether you are getting this or not. Fine. Now what will happen? See, this one and this one is going to cancel. So you're only left with minus a by x root a square minus x square, and that is your answer. I hope this is clear.
Sir, I didn't got
Tell me
the second last part. How you got that numerator?
how I got that in the numerator. See, I have
Yes,
a
sir.
minus a here, isn't it? Root over of
Yes, sir.
a square minus x square, and I've got a minus a square here. So from here and here, if I take the HCF out, which is minus a, then what will be left?
Oh, okay, sir.
This will be left, right?
Yes,
Fine.
sir.
So that is what I have done.
Like later a square into front.
Yes, exactly. After cancelling out minus x square and plus x square, you take your a common, and you'll be left with this only. So that now they'll get cancelled. Okay. So let us do the last sum of this exercise. The last sum of this exercise is if y is equal to, let me just check once more this sum, root over of x square plus 1 minus log 1 by x plus root 1 plus 1 by x square, find divide dx. Let us start. What we do here is we first simplify y. So let's write y again. Given y is equal to root over of x square plus 1 minus log. Now you take the LCM. I have 1 plus square root 1 plus x square divided by x, right? And here you also have an x, isn't it? Minus, now you take the LCM, 1 plus root 1 plus x square divided by x, right? Now what you do here is This is log m by n form, the second one. So you write it as log m minus log n. Plus log x. Right? Now we shall start differentiating. Okay, see, why have I done this? You know, Devanjan, you understand why I simplified this?
So simplification too was needed.
I simplified this simply because, see, here I would have to use the u by v rule, isn't it? First, I will have to differentiate the log, and then I will have to use the u by v rule, isn't it? But if I
Yes, sir.
expand, but if I write it as log m minus log n, this one, then I don't have to use the u by v. That is why I have simplified this. Understood? So, I mean, it's always better to avoid u by v rule as much as possible, unless you are compelled to use a u by v rule. Because u by v rule, there are chances that you may make mistakes when sums as big as these are given. So now we'll differentiate this. Therefore, dy dx is equal to, first we'll differentiate this. What is the differentiation of this? 1 by 2 root. First you'll differentiate the radical, isn't it? Into the ddx of
Yes, sir.
whatever is inside the radical.
X plus plus.
Minus. Now when you differentiate log, you'll differentiate the log first. And then you'll differentiate what is inside the log. And similarly here, you differentiate log x to get 1 by x. And the next step, you carry out further differentiation. ddx x square, you know, is 2x, right?
X
Minus
1 0.
1 by 1 plus root 1 plus x square. One plus x square into now ddx of this. How do you differentiate? First you differentiate 1, you'll get 0, isn't it? Plus,
Yes, sir.
and then you differentiate root 1 plus x square. So what is the differentiation of root 1 plus x square? First you differentiate the radical to get 1 by 2 root 1 plus x square into the ddx of what is inside the radical, 1 plus x square, right?
Yes, sir.
And you write plus 1 by x as it is. Now in the next step, what happens? This 2 and this 2 will cancel out. You get x by root 1 x square plus 1 minus 1 by 1 plus root over of the 1 plus x square. Let's write it as x square plus 1. And here, what are you left with? You have 1 by 2 root x square plus 1 into ddx 1 plus x square, you know, is 2x, right? 0 plus 2x
Yes, sir.
plus 1 by x. Now this 2 and this 2 will cancel. Okay, now we'll see what we are getting. So we have x by root x square plus 1 minus, and here you have in the numerator, you simply have an x. In the denominator, you have root over of x square plus 1 into 1 plus root x square plus
X
1
square plus 1.
plus 1 by x. Okay. So now what you can do is you can take x common from the first two to get 1 by root x square plus 1 minus 1 by root x square plus 1 into 1 plus root x square plus 1 only from the first two. Why did I take x common? So that it will be a little easier for me to take the LCM. Okay. So what I do is now I take the LCM. LCM will be root x square plus 1 into 1 plus root x square plus 1. So in the numerator, you'll get 1 plus root x square plus 1 minus 1, I think, isn't it?
1.
Plus 1 by x. Now clearly plus 1 and minus 1 is going to cancel out. And once you cancel out plus 1 and minus 1, in fact, root x square plus 1 will also cancel out, isn't it?
Yes, sir.
So this
Yes, sir.
will also get cancelled out. So what you only left with is x by 1 plus root x square plus 1 plus 1 by x. And that is your answer. Clear? So why have I done these problems with you? These problems were long, I mean, very remote chances that these are going to come in your examination. But I worked this out so that you are confident in your differentiation. I have taken you to an altogether different level so that the easier problem when they are posed, you'll be able to do them with confidence. So if you are able to do these problems, these are quite lengthy and tedious problems. If you're able to do these problems, you'll be more confident. Okay, because the kind of problems that are given are not as tedious as these. Let us now look at the next part, which is differentiation of exponential and logarithmic functions. Sorry, exponential function only. Differentiation of exponential functions. Okay, under this, you must know is that the ddx of e to the power of x
Easy.
is e to the power of x. Now, what you must note is that from chain rules, it can be shown very easily. From chain rules, I'm not showing you, but just remember this, that from chain rules, it can be very easily be shown that e to the power of any function, in differentiation, in fact, differentiation of e to the power of any function is carried out in a way that we first differentiate e to get e to the power of fx, right? And then we differentiate fx. Understood? So you get e to the power of fx into f dash x. So an example from this would be, let's take a very easy example to this. Let us take e to the power of cos x. Suppose I want to find out ddx e to the power of cos x. So how will I find this out? Just as in the above, we have first we'll differentiate e, right? To get e to the power of
Yes,
cos x into the ddx of cos x, right? As above I have told you. So now what will happen? ddx of cos x is minus sine. You will simply get
minus 1.
minus e to the power of cos x into sine x, and that is your answer. Okay, so that is how you differentiate this, and that was the first one. The second result that you must know is that ddx of a to the power of x. You know what is a? A is any real number. Is a to the power of x into ln a. Okay, natural log of a. Or you write e to the power of x log a also. Okay, this is the next result that you must know. Now what happened from chain rules? From chain rules, it can very easily be shown that ddx of a to the power of fx. How will you differentiate? First, you differentiate a to the power of x just as above here. So how much do you get? E to the power of fx into ln a, right? And then what you do is, then you differentiate fx. You understood what I said? a to the power of fx. Just as you differentiate here, you differentiate your a to the power of fx here to get this part, right? And then you differentiate the exponent, which is fx. Clear with this?
Yes, sir.
Let me see an example here. Suppose you want to carry out the differentiation of a to the power of sine x. Okay. If you want to carry out, let's say not a, let me take this as 10. 10 to the power of sine x, because a is a real number here. Okay, so how will you differentiate this? First, you will differentiate this according to this. So you have just have a look at the formula above, okay, as I am differentiating. You have 10 to the power of sine x into ln 10, isn't it? Right? And then what will you do? You will differentiate the exponent, which is sine x. Now just check. So d dx sine x is cos x. So you're simply getting cos x into 10 to the power of sine x ln 10. So I hope this is okay. I can proceed with a few sums now. Differentiate the following. First is e to the power of sine root x. Next one is e to the power of x square by 1 plus x square. Third one is 10 to the power of 10 to the power of x. Okay. Next is e to the power of x sine x. Okay. The next one is log e to the power of x by e to the power of x plus 1. The next one is e to the power of, let me take another one. Yes, e to the power of x minus e to the power of minus x by e to the power of x plus e to the power of minus x. One is 5 to the power of log sine x. Okay. Next you have e to the power of e. And next you have e to the power of log x plus square root x square minus a square. Okay. And finally e to the power of x log 1 plus x square. So very quickly let us work out these. These are not too difficult. Okay. This is I'm giving you just for practice, for your observation. Be very swift here. We start by saying let y is equal to e to the power of sine root x. Therefore, dy dx is equal to d dx e to the power of sine root x. How will you differentiate? Devanjan, tell me. First one. Just tell me, this will be your revision.
Yes, sir.
Tell me,
E
tell me.
to the power sine root x.
Okay, e to the power of sine root x. Then
Then ln e, I think.
into a differentiation of the power.
Yes, sir.
right?
Yes, sir.
So e to the power of sine root x into, now we differentiate sine root x. How do you differentiate sine root x? First we differentiate sine,
Co-
cos root x
Yes, sir.
into the ddx of root x, right?
Yes, sir.
And finally you have e to the power of sine root x into cos root x, and you know the differentiation of root x to be 1 by 2 root x. So you simply get divided by 2 root x. Okay. Number 2. You have e to the power of x square by 1 plus x square. Divide dx will be, okay, help me out with this also.
E to the power x
Tell
square
me.
by 1 plus x square.
First e to the
E
power
to
of
the
x,
power x square by, yes, sir.
1 plus x square, and then,
Then ddx of the power.
yes, then the differentiation of the power. And how will I differentiate this x square by 1 plus x square? You can use u by v rule directly, no problem.
Okay.
V ddx of u, I'm doing directly, okay? ddx of u is 2x minus u here is x square into ddx of v. What is differentiation of 1 plus x square? 2x. 0 plus 2x, isn't it?
2x.
Divided
Yes,
by
sir.
square of the denominator. You understood the differentiation because I did this directly.
Yes, sir. Yes.
Okay.
Okay, sir.
E to the power of x square by 1 plus x square. Now you simplify this. You get 2x plus 2x cube minus 2x cube divided by 1 plus x square square. So that this and this will cancel off. You simply get 2x e to the power of x square by 1 plus x square divided by 1 plus x square whole square, and that is your answer. And the last sum, I'll continue next week after this. The next sum I gave you was 10 to the power of 10 to the power of x. Very interesting sum. You got to do this a little in a step-by-step manner. Okay. Therefore, dy dx is equal to ddx of 10 to the power of 10 to the power of x. Now, how will you differentiate? First, you will differentiate this, right? To get what is the
Yes, sir.
differentiation of a to the power of x? It is e to the power of x, a to the power of this entire thing is x, x, 10 to the power of x,
Yes, sir.
into log of the base, log a, right?
Yes, sir.
Into, now we'll differentiate this power. Okay. So now what does this become? 10 to the power of 10 power of x ln 10, and this is your again a to the power of x form. What is the differentiation of a to the power of x? It is a to the power of x into ln 10, isn't it?
Yes, sir. Yes, sir.
So now we have got our answer. So our answer is 10 to the power of 10 to the power of x into 10 to the power of x into ln 10 whole square. Okay. So finally, you can add another step. You can add the powers also, as x into ln 10 whole square. And that is your answer. Okay. So I'll stop here for today.